Good day, sir. Presenting the Group F. We have here three problems which embodies the three types of belts, which are the flat belt, V-belt, and circular belt or rope. For problem number 1, a flat belt 8 mm thick and 100 mm wide transmits power between two pulleys, running at 1,600 meters per minute. The mass of the belt is 0.9 kg per meter length. The angle of lap in the smaller pulley is 165 degrees and the coefficient of friction between the belt and pulley is 0.3. If the maximum permissible stress in the belt is 2 meganewton per meter squared, find the maximum power transmitted and the initial tension in the belt.
Good day, sir. I'm Jillian J. Lawas. So in this problem number 1, we have the following given. T is equal to 8 mm, which is the thickness. B is equal to 100 mm, which is the width. V is equal to 1,600 meter per minute, which is the velocity. M is equal to 0.9 kg per meter, which is the mass. We also have here the angle of lap in radian, which is 2.88. The maximum permissible stress is equal to 2 meganewton per meter squared, and lastly, the coefficient of friction between the belt and the pulley is 0.3. So the required in this problem is first is the maximum power transmitted, and second, the initial tension of the belt. So first, in determining the maximum power transmitted, the formula being used is that P is equals to T1 minus T2 times V, where T1 is equals to the tension in the belt on the tight side and T2 is the tension in the slack side, and velocity in meter per second. However, we don't have the value for T1 and T2 yet, so we need to solve first the T1 and T2 using the respective formula. So step 1. TC, or centrifugal tension, and the maximum tension is solved first for us to get the T1. TC is equals to M times V squared, where M is equals to 0.9 kg per meter. V is equals to 26.67 meter per second, in which the 1,600 meter per minute is being converted to meter per second. Then substitute, then TC is equals to 0.9 kg per meter times the 26.67 meter per second squared is equals to 640 Newton. That is the value of the centrifugal tension or TC. So afterwards, the maximum tension, which is the value of T, was being calculated with the formula maximum stress in Newton per millimeter squared or Newton per meter squared times the width of the belt in millimeter or meter times the thickness of the belt in millimeter or meter also. Since the given stress is 1 meganewton per meter squared, we need to convert this first into Newton per meter squared, where ang 1 meganewton is equals to 1 times 10 raised to 6 Newton, and the width and thickness of the belt is converted into meter. So T is equals to 2 times 10 raised to 6 times 0.1 meter times 8 times 10 raised to negative 3 meter. So the value of T will be 1,600 Newton. Thus, you can now solve for the value of T1 by using the formula T is equals to T1 plus TC. Just substitute the value of T and TC, where T is equals to 1,600 Newton and TC is equals to 640 Newton. Hence, ang value of sa T1 is equals to 960 Newton.
Good day, sir. I am Justin May Pelos from BSME 3. So I'm going to discuss the T2 and the power transmitted by the belt. So step 3. Solving for T2 with the use of ratio of driving tension in the belt. Since we already have the value of T1, we can now substitute the T1 in the formula of ratio tension in the belt. So the formula is T1 over T2 is equals to E to the power of the coefficient of friction times the angle of lap, or log E times the quantity of T1 over T2 is equals to coefficient of friction times the angle of lap. So now we need to substitute the value of for T1 T1 is coefficient of friction and the angle of lap. So the 960 Newton is the T1 over T2 is equals to the E to the power of coefficient of friction, the 10.3 times 2.88, the angle of lap. So now we have already the T2. T2 is equals to 404 times 61 Newton. Next is step 4. Thus, we can now solve the power transmitted by the belt. So the formula is P is equals T1 minus T2 times the velocity, where T1 is 960 Newton and T2 is equals to 404.61 Newton and the velocity is 26.67 meter per second. So substitute the value of each. So T1 is 960 Newton minus 404.61 Newton times 26.67 meter per second. So it is equal to 14,812.25 Newton meter per second or watt. So we need to convert watt to kilowatt. So 14,812.25 watt times the quantity of 1 kilowatt over 1,000 watt. So the power transmitted by the belt is 14.81 kilowatt, which approximately to 14.83 kilowatt.
Good day, sir. I am Michael Angelo Lato from BSME 3B. So for letter B, number 1, the initial tension in the belt centrifugal tension is considered. So the formula is TO is equals to T1 plus T2 plus 2TC divided by 2, where the T1 is 960 N and the T2 is 404.61 N and the TC is equals to 640 N. So let's solve the TO. TO is equals to 960 plus 404.61 plus 2 times 640 divided by 2. So the answer is TO is equals to 1322.305 Newton.
For problem number 2, power transmitted between two shafts by a V-belt whose mass is 0.9 kg per meter length, the maximum permissible tension in the belt is limited to 2.2 kN. The angle of lap is 170 degrees and the groove angle is 45 degrees. If the coefficient of friction between the belt and pulley is 0.17, find the velocity of the belt for maximum power and the power transmitted at this velocity.
Good day, sir. I am Von Christian Catedilla. So in this problem 2, we have this following given. Which is the mass, is equals to 0.9 kg per meter. Then the maximum permissible tension is equals to 2.2 kN. Then angle of lap is equals to 170 degrees. Then we will convert it to radians. So 170 degrees times pi over 80 is equals to 2.767 radians. And the groove angle, which is 2 beta, is equals to 45 degrees divided by 2 to cancel out the 2. So we have beta is equals to 22.5 degrees. Solution A. For the velocity of the belt maximum power, we have the derived formula from T minus 3 times mass times the velocity squared is equals to 0, which is the different calculated equation from the expression with respect to V. So, this formula being used, V is equals to square root of T over 3m that derived from T minus 3 times mass times velocity squared is equals to 0. So V is equals to square root of T over 3m, where T is equals to 2.2 kilonewton, which need to be converted into Newton to obtain the unit for velocity, which is meter per second. So we substitute the given V is equals to the square root of 2.2 kilonewton times the quantity of 1000 Newton over 1 kilonewton over 3 times the quantity of 0.9 kilogram per meter. Thus, we have the velocity of 28.54 meter per second.
Today, I am Reno M. Nunez, a BSME 3A student. For the power transmitted at this velocity, we know that P equals the quantity of T1 minus T2 times velocity. Step 1 for T1 equals to T minus Tc. So we already have the mass 0.9 kilograms per meter and velocity in letter A, which is 28.54 meter per second, where Tc equals to mass times velocity squared, so equals to 0.9 kilograms per meter times the quantity of 28.54 meter per second raised to the power of 2. So our Tc is 733.1 Newton. Since we already have the value for T, which is 2.2 kilonewton or 2,200 Newton, we can now proceed in solving the T1. So T1 equals to 2,200 Newton minus 731.1 Newton is equals to, our T1 is 1,466.9 Newton.
Good day, sir. I am Raymart Sicolaba, BSME 3A. For step 2, we already have T1, so let's now solve for T2. The formula of the ratio of grabbing tension in B-belt, we use the formula which is 2.3 log times the quantity of T1 over T2 is equals to the coefficient of friction times the angle of lap times cosecant beta, where cosecant x is equals to 1 over sine x. So substitute the given for the coefficient of friction or mu is 0.17 times 2.967 rad times the quantity of 1 over sine times the quantity of 22.5. So it is equal to 1.318. We get 2.967 rad because the angle of lap is 160 degree times the quantity of pi over 180. So we get 2.967 rad. For the angle of groove, which is 2 beta is equals to 45 degree, then divided by 2 to get 22.5. So 2.3 log times the quantity of 1,466.9 Newton, or this is our T1, divided by T2 is equals to 1.318, and then cross multiply. So log times the quantity of 1,466.9 Newton over T2 is equals to 1.318 over 2.3, then shift solve. So T2 is equals to 392.06 Newton.
Good afternoon. I'm Mark G. Chipes. Discussion about step 3. Thus, for the power transmitted in this velocity, P for power transmitted equals T1 minus T2 multiplied by B for velocity. For T1, 1,466.9 Newton minus for T2, 392.10 Newton multiplied by velocity 28.54 meter per second, and the answer is 30,674.792 Newton meter per second multiplied by watts. 1 kilowatts over 1000 watts and cancelled watts, and the final answer is P equals 30.7 kilowatts.
For problem number 3, a rope drive is required to transmit 230 kilowatts from a pulley of 1 meter diameter running at 450 RPM. The safe pull in each rope is 800 Newton and the mass of the rope is 0.46 kg per meter length. The angle of lap and the groove angle is 160 degrees and 45 degrees respectively. If the coefficient of friction between the rope and the pulley is 0.3, find the number of ropes required.
Good day everyone, I am Leonido Altor, a BSME student. At this point, I will be enumerating the givens of the problem number 3. So we have the power, which P is equal to 230 kilowatts, and we have the diameter, which is D is equal to 1 meter, and also we have the rotational speed which is N is equal to 450 RPM or revolution per minute. And we have the tension, which is T is equal to 800 Newton. And also the mass, we have the M is equal to 0.46 kilogram per minute. And also the angle of flap, which we will convert the given degree into radians. So it will be 160 degree multiplied by pi over 180. So it will become 2.79 radians. And we have 2 beta, which the groove angle is equal to 45 degree, and it will be divided into 2. So beta is equal to 22.5 degree. And the coefficient of friction, which is equal to 0.3. So the required of this problem is to find the number of ropes. So in step 1, which is to solve for the velocity of the rope and the centrifugal tension. So the formula for the velocity of the rope, we have the V is equal to pi d times n over 60. So let's substitute the value of d, the diameter, over 60. So let's substitute the value of d, the diameter, which is 1 meter, and the rotational speed of the n, which is 450 rpm over 60 seconds, and it will be 23.562 meter per second. So to solve the centrifugal tension, the formula we are going to use is Tc is equal to m times v squared. So let's substitute the mass by 0.46 kilogram and multiplied by the value of the velocity of the rope, which is 23.562 meter per second squared. So it will be equal to 255.377 Newton.
Good day, sir. I am Darrell Dave D. Calimoso. For step 2, we need to solve the tight and side slack of the rope, since the T1 and T2 are involved in the formula in finding the number of ropes. As we all know, T1 is equals to T minus Tc. Since we have values for Tc and T, we just substitute the values on the given formula. So T1 is equals to T minus Tc. T1 is equals to 800 Newton minus 255.377 Newton. So T1 is equals to 544.623 Newton. While for T2, the ratio of the driving tension is used. We know that 2.3 log times T1 over T2 is equals to coefficient of friction times theta cosec beta, in which the values for T1, coefficient of friction, theta, cosec, and beta is already given. So 2.3 log times T1 over T2 equals 0.3 times 2.79 times the cosec, or 1 sine 22.5, which is equals to 2.1873. So log times 544.623 Newton over T2 is equals to 21873 divided by 2.3. So the value for T2 is equals to 60.97 Newton.
Good morning, sir. I'm Rafael Katambag from BSME 3A. For the last step, the number of ropes is being calculated using the formula total power transmitted over power transmitted per rope. For the power transmitted per rope, we have here the P is equal to T1 minus T2 times B, where the calculated T1 is 544.67 and T2 is 60.967 and V is 23.56. Substitute to the given formula, so the power transmitted per rope is 11,395.595 watts or 11.396 kilowatts. Substitute this value to the formula in finding the number of ropes. While the total power of transmitted was already given in the problem, thus the calculated number of ropes is 20 and 18. However, that is not our final answer, since we were talking about ropes. Here we need to round off the answer into 21, since our calculated answer has an excess of 18. This happened for the reason that, for example, sir, og sa planta pa kinahanglan na allowance and clearance kay once gani ang usa ka material maapektuhan sa temperature nga init og bugnaw man gani na ay possibility nga kanang mo expand.
And that's all. Thank you.